This video was brought to you by the ILC. Hi there once again. Welcome to episode 23. In our previous episodes, we've talked a little bit about finding the domain of a function, and we've also talked about finding a composite function. In this episode, we'll combine the two concepts, and we'll try to find the domain of a composite function. Let's have a look. Our functions for this problem are fx equals root x divided by x minus 3, and gx equals x plus 2. Our goal will be to find the domain of the composite function. Now, before we address the composite function, we first have to find the domain of the f and g. So we'll start with the domain of f, and let's think about what sort of restrictions we'd have for f. If you'll recall, there are two ways to get restrictions on a function's domain. The first we have on the top. There's a root sign. That will influence the domain. We also have a denominator of a fraction down on the bottom. If you'll also recall, the things inside of a root must be greater than or equal to 0, and the things in the fraction cannot equal 0. Based on that, we can try to figure out what the restrictions are. From the root, we have x is greater than or equal to 0, and from the fraction we have x minus 3 is not equal to 0. If we add 3 to both sides, we'll simply have x is not equal to 3. Those are our first two restrictions from f. Let's also look at the domain of g. Now we might notice that for g we just have x plus 2. There are no roots, and there are no fractions, therefore we have no restrictions. Based on that, we can draw a picture. We'll draw our arrows and our number line here at the bottom. Our left arrow is negative infinity. Our right arrow is positive infinity, like always. Let's mark down our points of interest. Our first point of interest will be 0, here in the middle, and 3, here on the right side. Now we'll have to say that everything greater than or equal to 0 is okay, so everything less than 0 is automatically excluded from the domain. There we are. Also, x cannot equal 3, so we'll put an open circle at 3. Now this is only going to be part of the answer. Now that we've graphed out the restrictions from both f and g, let's find the composite function and try to figure out the restrictions from that. So we'll do a section below that for the domain of f composite g. We begin by writing f, as always, root x divided by x minus 3. Replace all of the x's with g's. So now it's root g divided by g minus 3. Then replace the g's with their function. We'll now have root x plus 2 divided by x plus 2 minus 3. If we simplify this, we'll have root x plus 2 divided by x minus 1. We now have a different set of restrictions. We have a root on top, which is different from the one we had before, and we now have a different denominator than the one we had before. So our root and the bottom of our fraction will give us a different set of restrictions. Let's figure out what they are. From the root, we can say x plus 2 has to be greater than 0, so x is greater than or equal to negative 2. You might notice negative 2 is already in the restricted area, so this won't have any influence on our domain, since it's already restricted. Our fraction, on the other hand, might give us something new. We know that a fraction cannot equal 0, so we'll say x minus 1 is not equal to 0, therefore x is not equal to 1. 1 would fall here on the number line. So that's a restriction we didn't have before. We'll have to mark that down and put an open circle to show that it can't be 1 either. So these open circles will split our domain into 3 regions. We'll label this 0 to 1 as region A, 1 to 3 as region B, and 3 to infinity as region C. Now, we are allowed to include 0 because earlier, back in our first restriction that we checked, it said x could be greater than or equal to 0. So we'll fill in 0, and every region in between the open circles is okay. There we are. So to write the domain, we look at region A. It goes from 0 to 1. Union, region B, goes from 1 to 3. Region C goes from 3 to infinity. Now, since we include 0, we place a bracket, but we do not include 1, we do not include 3, and infinity isn't a real number, so that's always parentheses. And there we go. Here's our domain. 0 to 1, union 1 to 3, union 3 to infinity. And there you have it. Thanks very much for watching. We'll see you again next episode.